Okay, this video is on inverse of a matrix, section 8.3. Okay, so it's important to talk about where the inverse of a matrix comes from. So we talked about matrix equations yesterday. So let's say you were given the matrix equation AX equals C. Okay? And you were given matrix A, and you were given matrix C, and you were told that you needed to figure out what matrix X was. Okay? Now, you would want to divide, okay, to figure out what matrix X was. You would want to take C and divide it by A. But we have no such thing as division when we talk about matrices. So, in order to do that, it's similar to a problem that would look like this. Where I have 2/3 x equals 6. And in order to solve 2/3 x equals 6, I would want to multiply both sides by the reciprocal, which would be 3/2. Which would allow me to solve for x, okay, and get 9. In order to solve back up here to our matrix equation, AX equals C, we are going to keep the idea of a reciprocal in mind, except when we talk about this in terms of matrices, it would be known as the inverse of a matrix. So, and this is written A to the -1, so the inverse of matrix A. Now back up to our problem where we were trying to solve AX equals C. Okay. I want to multiply my left-hand side by the inverse matrix. So that would look like this. A -1 times A X equals, and you need to remember that order matters when you're multiplying matrices. So if I did A to the -1 first over here, I also need to have A to the -1 times C on the right-hand side. Now, up here, when we multiplied by 3/2 times 2/3 and got X, really we got 1. We just don't write the 1. 1 is also known as identity. Well, a similar thing is going to happen here. A to the -1, or the inverse of matrix A, times A, is going to give me just X, but I have this I written in front of there because it really gives me the identity matrix. And that equals A to the -1 times C, which is really X is equal to A to the -1 times C. And the identity matrix is something that we've talked about. The identity matrix is actually reduced row echelon form. So we're going to be using that matrix of zeros and ones to help us solve or find the inverses of matrices. Okay? I think it would work best if we just started with an example. So we are going to find the inverse matrix. So we're going to find whatever we need to multiply our A by in order to get just X if we wrote the equation. So let's find the inverse if A is the matrix 1, 3, 3, 1, 4, 3, 1, 3, 4. And we are looking for A to the negative 1. That's our ultimate goal. The first step here is that I am going to adjoin this matrix, much like you augmented a matrix. So this is matrix A. And then on the right-hand side of my adjoining matrix, I am going to put the identity matrix. And remember, I said the identity matrix is that matrix of zeros and ones. So we had 1, 0, 0, 0, 1, 0, and 0, 0, 1. Okay. Now, your ultimate goal is to get this left-hand side, so the left hand of the dashes, to be the identity matrix. And then what's going to happen is our right-hand side is going to become A to the negative 1. Now, how are you going to translate the left-hand side into the identity matrix? Well, you know how to translate the matrices into the identity matrix. You're going to have to do row operations. Okay? In order to transform left side to identity matrix. So essentially, I want 1, 0, 0, 0, 1, 0, and then 0, 0, 1. Now, just like you did before, you're also going to have to do all of your operations to this right-hand side, and that's where the inverse matrix is going to come. So, much like we did when we got things into reduced row echelon form, I cannot tell you exactly how to do these problems. However, it is kind of already set up. I already have a 1 here, so I think my first row operation is going to be negative 1, row 1, plus row 2. Okay. Now, row 3 is not going to change, and neither is row 1. So I'm going to rewrite those numbers, much like you've already done. Okay. Now I'm doing negative 1, row 1, plus row 2. So negative 1 times 1 plus this 1 would be 0. Negative 1 times 3 plus 4 would be 1. Negative 1 times 3 plus 3 would give me 0 here. Then I need to keep going, so negative 1 times 1 plus 0 would give me negative 1. Negative 1 times 0 is 0, plus 1, this is a 1. Negative 1 times 0 plus 0 is 0. Now remember, we're not as concerned with what happens with this right-hand side. Yes, I need to perform all of my row operations, but we're just concerned with getting 1, 0, 0, 0, 1, 0, and 1, 0, 0. So now, I think I'm going to work on getting this to be a 0. So now I'm going to do negative 1, row 1, plus row 3. And again, this is just like the row operations we already did. So my row 1 is not going to change. I'm going to go ahead and write down what I had there. And my row 2 is not going to change. So now I'm going to work with my row 3. So negative 1 times 1 is negative 1, plus 1 gets me the 0 there. Negative 1 times 3 plus 3 gets me a 0. Negative 1 times 3 is negative 3, plus 4 should get me a 1. And then we need to remember we're also doing it to this right-hand side. So negative 1 times 1 is negative 1, plus 0 would be negative 1. Negative 1 times 0 plus 0 would be 0. Then we have negative 1 times 0 plus 1. This would be a 1. Okay, now if you look at what we've done so far, I've got all of my zeros below, all of the 1s, and I've got a 0 here. Now I just need both of these 3s to be zeros, much like you've already done before. So I'm going to do 3 times row 3, and actually it needs to be a negative 3, plus row 1. And that will get me a new row 1, which will eliminate this last 3. So again, my row 2 is not changing, so I go ahead and copy that down. My row 3 is not changing, so I'm going to go ahead and copy that one down. Okay. Negative 3 times 0 is 0, plus 1 would be 1. Negative 3 times 0 would be 0. Plus 3, right there, would be a 3. Negative 3 times 1 plus the 3 I have right here would make this entry 0. Negative 3 times a negative 1 would be positive 3, plus the 1 I already have there would make this entry 4. negative 3 times 0 would be 0 plus 0 there. This would be a 0. Negative 3 times 1 would be negative 3 plus the 0. This would be a negative 3. Now I have one last step to do. I want to get this 3 to be a 0. So I am going to take negative 3 row 2 and add that to row 1. Negative 3 row 2 plus row 1. I'm going to try to leave that on the screen so you can see what I'm doing. Okay, this will again give me a new row 1. So I'm going to go ahead and copy down row 3 and row 2 exactly as they are in the upper matrix. Okay, now I'm doing negative 3 row 2 plus row 1. So I would start here. Negative 3 times 0, that's 0. Plus the 1 I have up here, that's a 1. Negative 3 times 1 would be negative 3. Plus the 3 up here would make that 0. Negative 3 times 0 is 0. Plus the 0 I already have would make that 0. And if you look, I have the identity matrix that I needed. Now I just need to finish my right-hand side. That will tell me what my A inverse is. Okay? So, negative 3 times a negative 1 would give me positive 3, and then if you look, I already have a 4, so that would be 7. Negative 3 times 0 would be would be 0, so I'd have a 0 here. Oh, except I made a mistake, so let's stop. I multiplied by 0, which is row 3, but I'm multiplying by row 2 right here. So I'd really be doing negative 3 times 1. This entry should be a negative 3. And then I need to do negative 3 times 0 plus negative 3, so my last entry should also be a negative 3. Okay, this means that the inverse of matrix A is 7, negative 3, negative 3, negative 1, 1, 0, negative 1, 0, and 1. So you have just found the inverse of matrix A because your left-hand side has all of the 1s and your right-hand side represents your inverse of matrix A. This is going to be very helpful for you when we start to try to solve systems of equations again using the inverse and then the identity.